If you boarded a spaceship, locked the navigation computer to a single direction, and flew forward forever, what happens? Do you eventually crash into a cosmic wall or simply slip off the edge of reality? We know our universe has a finite age. It was born in the Big Bang roughly 13.8 billion years ago. Because nothing travels faster than the speed of light, logic dictates a very neat boundary. If light has only been traveling for 13.8 billion years, the universe should be exactly 13.8 billion light years wide. Curious tone, but when astronomers actually measure the diameter of the universe we can see, the math breaks down. The true diameter is a staggering 93 billion light years across. To understand why those numbers clash, we have to answer three questions. How far can our telescope see? Why is our vision strictly blocked? What exists in the dark beyond? The night sky hides a lie of scale. We are permanently locked inside a tiny, finite cage, seeing only a fraction of the total expanse. Think of standing on the deck of a ship in the middle of the ocean. Your vision extends perfectly in every direction until it hits the horizon line. But the ocean doesn't stop there. The curvature of the Earth simply hides the water beyond it. Earth experiences the exact same phenomenon in space. We sit dead center inside a massive sphere, 93 billion light-years across. Astronomers call this bubble the observable universe. The edge of this bubble is called the surface of last scattering. It represents the absolute oldest light that has had enough time to physically travel through space and hit our telescope lenses. This oval-shaped map shows the cosmic microwave background. Those blue and orange speckles represent the leftover radiation from the Big Bang. When we look as far into the cosmos as possible, this is what we see, a glowing wall marking the absolute limit of human sight. This glowing barrier is an optical horizon, a limit created by the finite speed of light rather than a physical end to space itself. If you teleported to a galaxy right on that edge, you would simply be at the center of your own, entirely different 93 billion light-year bubble. But that brings us back to the math problem. How does light traveling for only 13.8 billion years create a visible bubble that stretches 93 billion light-years across? The answer lies in a quirk of physics. Light has a strict absolute speed limit through space, but the fabric of space itself has no speed limit whatsoever. The fabric of space constantly stretches in all directions. Light from the most distant galaxies took 13.8 billion years to reach us. But during that journey, expanding space simultaneously pushed those host galaxies outward. Today, they sit roughly 46.5 billion light-years away. Distance in the deep cosmos is an illusion. Our cosmic horizon is constantly being dragged outward because space is stretching out from under us. So if we could somehow bypass the speed of light and step completely outside our 93 billion light-year bubble, what exists in the dark on the other side? To figure that out, astrophysicists look at data from the Planck satellite, an observatory designed to map out the overall geometric shape of the universe. By measuring the density of energy and matter, the Planck data revealed a startling conclusion. Our universe is topologically flat. That means space does not bend or curve back in on itself to form a closed shape like a sphere. In cosmology, a flat geometry has a very specific consequence. If the universe doesn't curve into a closed shape that loops back around, it simply continues outward in straight lines, forever. Our 93 billion light-year bubble is just one finite room inside an infinitely large mansion. The true universe outside our view is endless. That infinite scale introduces a deeply unsettling complication. Not only is the universe expanding, but that expansion is accelerating over time. Because space itself has no speed limit, the compounding rate of expansion means galaxies at the very edge of our observable bubble are now being pushed away from us faster than the speed of light. Astronomers call this superluminal expansion. The grim consequence is that the stars we can barely see at the edges of our sky tonight are actively slipping over our cosmic horizon. Once they cross that threshold, their light will never reach us again. They are permanently lost to the void. This leads to a theory proposed by cosmologist Max Tegmark, who looked at the pure mathematical consequences of a space that never ends. Tegmark's logic relies on the fact that a single bubble of space can only hold a finite number of atoms in a finite number of positions. If you extend that space infinitely, the universe eventually runs out of unique combinations. At distances so large they exceed human notation, the math forces atoms to assemble into the same patterns again. Eventually, those patterns must reconstruct entire planets, cities, and even people, including a version of you living this exact moment. We are left with a strange paradox. The universe is expanding so aggressively that we will eventually be completely blind to the wider cosmos. Yet space is so infinitely vast that we are mathematically guaranteed not to be alone in it. Which concept keeps you up at night? The fact that the distant stars are slowly disappearing from our sky forever, or the idea that exact copies of us are living out their lives somewhere deep in the dark? Let us know down in the comments, and don't forget to subscribe.